Alright boys and girls, welcome back to the Rock the JVM channel. I'm Daniel, and in this video I'm going to discuss given and using clauses in Scala 3. So in this video we will take a structured look at the new given using clauses in Scala 3, which will promise to be a big leap forward compared to Scala 2. Now, unlike other posts and videos on this topic that you will find on the web, this video and the accompanying article is also approachable for beginners. So all I need from you is simple curiosity about this new given and using mechanism here in Scala 3. Now, this pair is often compared with implicits, which are themselves really powerful and hard to learn if you're just starting out. But here in this video, I'll make no such references or assumptions. But it's a bonus if you do know how implicits work. As always, I'll recommend that you code with me, and whenever you need to refresh your memory about these concepts, just refer back to this video or to its written form on the blog. And here we will celebrate our 50th blog post on the blog here at Rock the JVM, so definitely check this out. Alright, so when you're ready, just hit a thumbs up to this video and let's get started. So, I have here in my code editor a simple Scala 3 project, which can be created in IntelliJ IDEA by simply going to File, New Project, and selecting here Dotty on the right hand side. So select here Scala if you have the Scala plugin installed, and select Dotty, which will contain all the features that we're going to need for this video. And after that, you can simply click on next and then follow the same wizard that you're used to from other projects that you may have created. So here's the situation. Let's say we write a nationwide census application. So we deal with persons all the time. And something like the following case class, perhaps with more fields, would be used everywhere. And I'm going to define a case class. I'm going to call this person with a name. I'm going to call this surname as a string, a name as a string, and an age as an int. In a real life application, this data structure will contain many more fields. But assume that we have this simple case class, which is used basically everywhere in our application. So it would make sense for instances of this person class to be ordered in various data structures. But we don't have a natural ordering of persons. So for applications like these, ordering persons needs to have some sort of a standard algorithm, usually alphabetically by surname. So we would define a value, let's call this person ordering, as an ordering person. Now, you can use any kind of comparison data structure that you like. I'm going to use ordering, which is already part of the Scala standard package. And I'm going to simply use a new ordering person, where the compare method will compare to persons X and Y, and I'm going to simply compare them by surname. And I'm going to use the Java compare to function on strings. So I'm going to say x.surname.compare to y.surname, and I'm going to simply leave it at that because the compare function returns an int. And if the int value here is negative, then x is deemed to be quote unquote less than or before y. Otherwise, y is less than x. All right. So this will be a natural ordering of persons. So in other words, we need a single standard ordering of persons that we could use everywhere. So I'm going to simply use everywhere. All right, now at the same time, making this instance available and using it explicitly would make the code kind of cumbersome because such a standard ordering is assumed, and as a developer, we simply want to focus on the logic at hand rather than pass the same standard value all the time. So for example, if I had a method, let's call this list people, which had persons as a sequence of person, and in another argument list, I'm gonna have an ordering of person, and let's assume that this method is implemented, and I'm going to, I don't know, return a seek a person. And I had a bunch of other methods. For example, if I had some other method requiring ordering that takes Alice as a person and Bob as a person and an ordering. So an ordering as an ordering person. And I'm going to return, for example, a number to do some sort of difference between Alice and Bob. So who knows what kind of methods you might need for this census application, but assume that there are quite a few, and all of them require this ordering of person as a separate argument list. Now, when we call these methods, we need to do two things. First of all, find the standard value. that is in the code and also plug it into all of these methods. So we need to explicitly call these methods with the ordering as the second argument list. Now, this is a pretty menial task that we can delegate to the compiler, and so given and using clauses were invented. So we will change our code in two small ways. First, our standard ordering here will be considered a given value, that is an automatically created instance which is readily available to be injected in the right place, with quotes. The right place is something that we're also going to define. So the structure of this declaration will look something like this. I'm going to define given, and I'm going to call this standard person ordering as ordering person. And then I'm going to open and close some curly braces, and I'm going to provide an implementation here. So I'm going to copy the content of the previous person ordering, and I'm going to simply snap that inside. So notice we aren't simply assigning this ordering instance to a value. We're simply marking this instance as a standard, also known as a given, and we attach a name to it. All right, so the name is useful so that we can reference this instance and use fields or methods on it, much like any other value in Scala. All right. However, we also need to mark the places where this given should automatically be injected. These are the so-called quote-unquote right places. So for this, we need to mark the relevant method arguments with the using clause. So I'm going to define, let's call this some method requiring standard ordering. And I'm going to pass a list of persons. So I'm going to say persons as a list person. And as a second argument list, I'm going to say using ordering as ordering person. And let's say this returns a list person, and this would be something with question marks. I don't really care what the implementation is. The signature is important. And this using clause is where this given instance would be automatically injected by the compiler. So if I do something like some method requiring standard ordering, so I'm going to simply call this method, and I'm going to pass a list of persons. So for example, I'm going to say person with Weasley, Ron, and 15 years old, and another person with Potter, Harry, with another 15 years old. Notice that this call is legit without me needing to supply the second argument list, because the compiler will simply inject the value given above. So the given is injected here. All right, so this second argument list is automatically injected by the compiler. Now, why do we need this? Well, this leads to much cleaner code. Especially in large function call chains, for example, if your method takes a large amount of arguments and or a large number of argument lists, and especially in large code bases. So the more code you have in your code base, then the cleaner this code will look like and the bigger the effect of givens is going to be. So this is, in a nutshell, how given using pairs work. Now, the compiler can inject a given instance where a using clause is if it has access to a given instance of this type, that is ordering person, in scope, in the scope where the method is being called. So if we continue this example here, a large-scale application will not be written in a single file and definitely in the same class. So we need a mechanism for importing given instances. So let's assume that this given instance stays in an object. I'm going to define an object. I'm going to call this standard values. And inside, I'm going to define this given. So I'm going to copy it and paste it here. I'm going to hit cancel here because the case class person is not available in this object. I'm going to make it top level. So I'm going to move it up, all right, so that the person class is visible for both the givens application and the standard values object. And notice that we have another given here in this object standard values. Now, assume we did not have this given that I defined earlier in scope, then notice that at the call site of this method, the compiler says no implicit ordering defined for blog person and so on and so forth. The implicit being the given instance. So this method requires a given given ordering person, which we do not have. And so we need to import one. And in order to import givens, we would need to write a standard Scala import to import this particular field. So we would say import standard values dot standard person ordering, and now the compiler error would disappear. So this is one. This is option number one to import explicitly. There are a bunch of other options here. You can say you can import a given instance for a type, not necessarily knowing what name that given value had. So import given for a type. That is because there can only be one given value for a given type, because otherwise, if I defined two given values for the same type, the compiler would not know which one to inject at the call site of the method requiring a given value, all right? So importing for a given type works because it needs to be the only one. And for this particular use case, I would import standard values dot, and I would open a curly brace and I would say given ordering person. So I would import the given ordering person that standard values object has. So I'm going to comment this one and I'm going to leave this one, and the code still compiles. There's also a third option to import all the givens. So you would say import standard values dot, and inside curly braces you would say given underscore. So if you say given underscore, then you would import all the given fields of this standard values object. Note that import standard values dot everything does not import givens. It only imports standard values, fields, classes, and methods. So this is how we would import a given value from any one place. Now, the next thing that I'm going to talk about is deriving givens. Because as we saw earlier, a given instance will be automatically created and injected where a using clause is present. So we can take this concept further. So we can ask, what if we already had a given instance that depends on another given instance via a using clause? So in Scala 3, we can create a given instance based on another given instance. So let me give a concrete example with this census application. So let's imagine that in our application, we have many types for which we have given instances of ordering. For example, we would have ordering person, we would have ordering cities, we would have ordering communities or workplaces or whatever a census application might contain. So we have a bunch of ordering values here. But in the meantime, because we're using pure functional programming to deal with value absence, we are working with options. So assume in our census application, we're working with options, and we need to compare these options too. So these methods that I described earlier, imagine that you had some generic methods that would imply using an ordering of your generic type T. So we would need to compare options too. So can we automatically create an ordering of option T if we had an ordering of T in scope? So the problem is create a given ordering of option T if we had a ordering T in scope. So this is the problem that we want to solve. And in Scala 3, with givens, we can. So I'm going to define a given. So I'm going to say given. I'm going to give this one a name. I'm going to say option ordering. And I'm going to also add a generic type argument T. You can add generic type argument to given definitions. And this given definition will require a using clause. So I'm going to say using. I'm going to call this normal ordering as ordering T. Now I need to give this one a type. So I'm going to say as ordering of option T. Right? And now I simply need to implement this ordering. So I'm going to define a compare function that takes two values x and y, both are option t's. And so I can implement that. So I'm going to say xy match, and in case I get a none and a none, I'm going to simply return 0. In case I get a none and something, I'm going to return -1. I'm going to simply assume that a none stays before a value. And in case I get something and none, I'm going to return 1. Right? And then if I write a case for A and B, so sum A and sum B, then I'm going to simply invoke this normal ordering that I have access to here. So I'm going to say normal ordering dot compare A and B. So this structure tells the compiler if you have a given instance of ordering T, then you can automatically create an instance of ordering option T with the implementation following these braces. So behind the scenes, the new given structure will work similar to a method. So if we ever need to call a method that takes a using clause with ordering T, then the compiler can automatically build the appropriate given instance. So if I write, for example, a def, let's call this sort things, which takes a type argument T and has things as a list of T and a using clause, so using ordering as ordering T. And I don't care about the actual implementation of this method. And somewhere else in the code, you have a value, let's call this maybe persons, which is a list of option person. And I'm going to simply create an empty list. And if I call sort things on this list, on maybe persons, then notice that the compiler does not complain because sort things requires an ordering of, and in my case, we need an option person. So we need an ordering for option person. And the compiler can automatically create an ordering for option person because it has an ordering of person in scope. So because we have a normal ordering as ordering of person in scope, the compiler can automatically build an ordering of option person, which it can then inject here. So the compiler will automatically inject the option ordering with the given standard value. So I'm going to say standard values dot standard person ordering. All right, so the compiler automatically injects these two calls inside for the other argument list. So this is how we can derive some extra givens. Now, where or why are these givens useful? Now, the problem that we started with is pretty small, but it's also the easiest to understand. Now, given and using clauses in combination with extension methods, which are almost as powerful, they combine to create some interesting effects. And these include type classes, dependency injection, also something that's cryptically called contextual abstractions. And I've simply pasted a line from the blog post, which is basically the ability to use some code for some types and not for others. So for example, here we have a sort things using an ordering of T. But if we don't have an ordering of T in scope, then we don't use this method. We cannot really use it. And so this is called a contextual abstraction. And among others, we have type level programming, which we have an entire series here on YouTube with implicits in Scala 2. I'm also going to bring that series up to speed when Scala 3 is out, and I'm going to update it with givens. So in the simplest terms, a using clause is a marker to the compiler so that if it can find a given instance of that type in the scope where the definition is used, for example, a method call here, then the compiler will simply take that given instance and inject it here. Now, the obvious restriction is that there cannot be two given instances of the same type in the same scope, because the compiler would not know which given instance to inject here. All right. Now, more philosophically, a given instance proves the existence of a type. So if the existence of a type can be proved by the compiler, new given instance can be created, which is what we did here a few minutes ago. So if they rely on a using clause, we can also create other given instances. So if we combine given and using combos for certain types, we can prove type relationships at compile time in a style that looks like the mini-series with type level programming in Scala. So in a future video, I'll show you how we can run type level computations with givens in Scala 3. So I hope you enjoyed this video and found it useful with given and using clauses in Scala 3, which promise to be really powerful. Check out the blog post because I also include some other niceties that you can use with given and using pairs. If you like this video, go ahead and click the like button for me and subscribe to the channel for more videos like this, and check out my work on Twitter and LinkedIn as I share updates on upcoming material every single day. In the meantime, leave out your comments. I'm dying for your feedback and I read every single one. And check out the Rock the JVM website. We have tons of material like this. Until next time, I'm Daniel, signing off.